Hi everyone. Hi, this is Priya here from Aarna Networks. Thank you everyone for joining out and taking your time from your busy schedule and being here with us today. We are back with our knowledge sharing session. Today's topic is on AMCOP O-RAN SMO, and we will do a feature demonstration of call home and demo. So I'm going to introduce to our presenter today, Yogendra Pal. He's a technologist at Aarna Networks. His expertise is in 5G RAN, security domain, and network infrastructure. Hi, Yogen. Welcome.
Hey, hi, Priya.
Yeah. We would love to hear all your queries, audience. However, it would be great if you can keep all your queries for your QA session, and at the end of the webinar, pop all your questions here in the chat box and we will try to reply to you. In case if you miss anything, don't worry. I'm recording the session and we can share on demand, and also we will publish it on our YouTube channel. Okay, Yogen, over to you.
Yeah, thank you.
Yes.
Can you give me the control?
Yes.
Okay, so let's get started. So today's agenda is primarily, to introduce about the call home feature, what is there in the ITF, and how it is getting utilized in the ORAN context. Right? So that is what we're going to talk about today, and we'll see, the network topology of how the live demo we have set it up today in the AMCOP, right? And what are the configurations one needs to do at the AMCOP side, so that anybody can exercise the call home feature. Right? So that's the in a nutshell we are going to try exercising this feature is all about, and in this webinar. So like Priya just mentioned, you can put up all the questions in the chat, or if you can hold on to your question till the end, then probably we can take up all the questions all together. Idea is that this session will connect a lot of dots, and then probably you can articulate your question, and then we can take up accordingly. Okay. So let's get started. So the call home is a feature which was standardized by the ITF, and they have formed the standard for that through an RFC called 8071. The link is present in the screen there. You can actually go and read in the detail about that. However, we'll talk about at a very high level what is the call home feature is and how does it work, right? And what are the characteristics of it, and then how does this feature is getting utilized in the ORAN perspective from the 5G, right? And how does that is consumed by one of the RAN elements, which is the radio unit itself, right? So we're going to talk about that in detail. Okay, so these are the two parts which is very important to go to the next step in terms of understanding the whole the live demo setup what we have planned up for today. Okay, so from ITF perspective, right? So call home is okay. So let me say this way. Let's start this way that a network device or RAN element, right, in the network can be configured by multiple ways, right? And traditionally there are two ways to look at it. One is top to down, and other is from bottom to up. When we say top to down, essentially what we're saying is you have a physical device, right, or the RAN network element, which could be a router, switches, or any of those such elements, right? So then what happens is you can have its own management plane, which will go and configure that once the device is up, right? So which means the management plane from the top is configuring the network element. That's one way. That's one approach, right? And then other approach is where you have the network element which boots up and comes up, and then you have pre-programmed it, or you have dynamically notified the network element that whom to contact, or who is the controller for this network device, right? This is what we call as the call home, essentially the second part, where from bottom to up we are just taking that approach, right? And this is essentially why it is required, because essentially when you deploy a network, right, what will happen is at the very first time you will bring up your network, you will define your the radio unit, you will define your your distributed unit and the central unit and many other devices in the network, right? At first time when you bring it up the setup, you configure them and then you let it deployed. And when it is in operational state, think about if a device goes down, all right? If a device goes down and it has to go back and connect to its controller, there has to be way to it, right? So that automation part has been taken care by the call home now. So what happens is you provision your network element and you specify it who is your controller. And once you provision that, automatically even the device goes down, and its startup configuration will have that information whom to reach out to. So that's the automation part of it, right? And the call home is the feature which is facilitating that. So call home is available in two flavors. One is through the netconf protocol, and another one is through the resconf protocol. Right. So here is on the right hand, if you see, there is a flow diagram which talks about how this call home works. So essentially, the prerequisite is you have a client server model, right? And you will have netconf or a resconf server, which is nothing but it's your physical device, or in the 5G context, we say it is a radio unit or a distributed unit or central unit based on whoever has implemented that functionality, right? So that's one. And the RESTconf client, what you see, right, or RESTconf netconf client, they are essentially the controllers, which can be a management plane controller. In 5G context, in ORAN, we say that it's an SMO. Okay. So how does it work is the server initiates the connection to the client. It starts a TCP connection. And when the netconf client accepts that TCP connection, it will initiate on the same connection an SSH or a TLS session. So it is riding on the same TCP session to the server. So that SSH session will get established with the netconf server, right? And after the SSH session is established, the netconf session will be initiated from the netconf client to the server. Okay, so here if you look at it, the whole flow is essentially the netconf server is initiating and reaching to its controller. Wherever in the first use case which I was mentioning from top to down model, it is always that netconf client will initiate the session directly to the netconf server, and after that it will bring up the SSH session, and then it will set up the netconf session underneath. Okay, so that's the fundamental difference between this step in the top-down model and the bottom-up approach. So here is some of the port numbers which has been defined by the ITF. So if you are using a netconf column feature with protocol SSH as a means to exercise it, then ITF has defined 4334 as a port number which will be used as a default port. Right? And it is riding on the TCP protocol, and this is meant for the SSH-based netconf. And similarly, you have for TLS-based netconf call home feature, wherein the port number would be 4335. And for RESTconf, it is 4336. Okay, so in today's webinar and the live demo, we're going to demonstrate the very first one, call home SSH-based. Now let's take a step back and look at from the perspective of ORAN. We had at least one view of how the ITF and the standard has defined the call home feature, right? Now that feature is getting actually utilized in the 5G context in the ORAN. Now in the ORAN, working group 4 has defined an plane specification for the radio unit, right? So in that they have two models, architecture models, in which the radio units will be communicating with the distributed unit, and there can be multiple netconf clients. So the very first model is on the right hand side, if you see, is the hierarchical model, where you have a radio unit which will be acting as your netconf server, right? And it will be talking to multiple netconf clients. And therein, you see there is only DUs which is talking to. It is not talking to any management plane element there. Essentially, the DU is managing the radio unit in this sense. Okay. This is one way of deployment, taking a use case where all the devices RU, DU, CU is coming from one vendor, in which case this is a very easy adaptation for the vendor. That's one way to look at. Second use case is where you have multi-vendor use case, right? Wherein there is a hybrid model, what we say. RU device act as a netconf server purely, and it talks to multiple DUs, which is your netconf client, and also talks to another controller, which is ORAN SMO. Okay, so essentially the netconf client is now spreaded across. So each of these elements are netconf client, and this is the netconf server. So this is the fundamental difference between the hybrid and hierarchical model, right? And the hybrid model actually enables multi-vendor and the opportunity in the 5G space, so that multiple companies can bring up their own network elements, and they should be able to collaborate and form a network stack solution for the 5G. Okay. So in today's demonstration, we are going to look at the hybrid model where ORE is communicating with an SMO, right? And SMO is acting as your netconf client for the column feature. So just continuing it and looking from the spec perspective, right? How does the column procedure has been defined in the working group 4? So here is a use case. So netconf client is one which is your ORAN SMO, or in our use case, it is AMCOP SMO. And you have a netconf server, which is your RU unit, right? So what will happen is when the RU unit boots up for the very first time, right? They will have a startup timer, column timer, which will be pre-provisioned, or it will be part of the startup configuration itself. And when the initial transport initialization is completed, right, they're going to start the timer. The timer is going to kick in with a TCP connection starting from the netconf server to the client. So this connection will be established, and that's where we're saying the netconf server initiates a TCP connection to the netconf client. Right, so the connection will be received by the netconf client. It will accept that connection, and it will initiate a SSH or TLS based on whatever has been hinted in the connection from this side, right? So it can take either SSH or a TLS based on whatever the capability both of them have it. So let's take an example. SSH session got established, right? So once this session is established, what will happen is over the same SSH connection, a netconf session will get established. It is going to ride on the SSH session, right? So that's where you see the netconf client is initiating the netconf hello capability exchange, and then the netconf server is going to reply back, right? And once this session is established, that's where the netconf server or the RU will stop the timer because session is established. There is a very common that RU can have multiple netconf clients attached to it, multiple controllers it can be attached to it. That's for the various reasons. Think about from active standby use case can be there, or even from the it is connected to the SMO, and it is also connected to the distributed unit DU also, right? So in that case, the DU can also act as a netconf client, right? So it has to go and connect to all of them. And as per the protocol, what happens is the RU is provisioned with this information that how many controllers it has it, and it will keep on trying to connect with them from this list. With whoever he has able to succeed it, right, that is going to remain connected. And for the ones which it fails, right, it will retry connecting it after periodic timeout. That periodic timeout is one of the parameters in the ORAN supervision.yang. So one can configure that parameter, and then according to that attribute, the netconf server, the RU is going to kick in its timer and periodically try to reconnect with the netconf client. Okay, so this is the successful use case. Now there will be another use case where things may not go properly or run into trouble issues, right? That's what has been shown in the abnormal procedure call. The same thing, the step number 1, you see, you send a TCP SYN, right? And then the client should, or the netconf client should, accept that connection, right? So it can fail for various reasons. So that's what we're showing is the TCP SYN ACK message, which is supposed to send by the netconf client to the RU, right? In this case, is not received, right? And essentially, once this has not received, your SSH and netconf sessions are obviously cannot be established, right? And that's where the call home timer expires, and it will retry that. It will repeat that procedure which I was mentioning. That one of the attributes which will be is there in the ORAN supervision.yang file that will dictate when to retry that. Okay, so this gives you at high level how the ORAN is consuming the call home feature for connecting the radio unit to its controller. Okay, now let's take the view from the AMCOP O-RAN SMO, what we have it at in our platform, right? So I'm going to show you that in our AMCOP SMO, which is a Kubernetes-based deployment we have one of the pods called SDNR, right? And this SDNR is basically riding on top of the on basically the open daylight features, right? So it rides on that. So if one has to go and check in their deployment whether the netconf column feature is whether there or not in the first place. If not, one can actually go ahead and install that feature. Right? It's very simple to install it. So this is one liner. So you have to connect to the pod, get into the prompt where this application is running, and just issue this command, feature install, and they keep the feature name, and it will install. Right. So one thing to note here is after installation is done, you can check that feature got installed or not. Okay. And post that, you have to validate that, like I was mentioning in the previous screen, right? The protocol number which has been assigned for the port number is 4334 for the SSH, right? Yeah, I'm trying to grab it, and I'm just showing it in red color here because our deployment doesn't listen on this port. It listens on the port number 666. This is primarily because of the open daylight has picked up 666 way before when the standardization has happened. Okay, so but it is a configurable parameter which you can set it, and it will the SDNR application will start listening on 4334. But for the demonstration of this demo, we are still listening on 666. Okay, and this is how you can validate that. Fine. Now, so once this pod is up and running, right? What we have to do is you have to do certain more configurations in order to allow the various SSH keys incoming from your from your netconf or netconf server or a radio unit for that matter, right? So we have to enable such credentials for it. So there are two curl commands which we execute, and I've just shown it here. But primarily it is nothing but facilitating the automation that any network operator can actually can either implement an OSS or BSS and can call the APIs, and it will set the respective credentials for the device which is trying to connect with the SMO. Okay, so it has to just connect to the ODL netconf call home server, and under the globals credential you have to fill in the credentials. So here what I have done is I've taken a username as admin and password as multiple passwords are there. I'll tell you why there is multiple passwords and why we have a single username. So essentially username is basically saying at global all the devices which is connecting to your controller will have a username as admin, and you may change the password over time because of the security reasons. So you just need to augment the existing configuration, right, in order to keep it, or even if you wanted to eliminate it, which is a good case, right, in order to maintain the security, right? So you can even eliminate it and keep a single password. So in this demo I'm just demonstrating both of them are present, right? And this is for the reason because I have two netconf servers which is running in the live demo, and one of them uses the admin password, another one uses the netconf password. And the usernames are also different. For one of the devices, it's admin username and password is admin. And for other one, username is netconf and password would be netconf. Okay. And then you have to allow one more configuration is to accept any SSH key coming from the netconf server. So that's where you have one more attribute, accept all SSH keys, set it to true. Once you do that, essentially your AMCOP is ready to take up the call home session coming from the RAN elements. Okay. Now let's take quickly how the topology looks like. So what we have done is we have in the AWS cloud, we have spin up the K8s cluster, and this is where you have the AMCOP SMO is deployed, right? And in the same deployment, we also have it on the same host machine, two netconf servers. One we have taken as a ConfD, which is a very renowned from the Cisco, and other one is the open source NetOPER 2 server we have taken, right? Both of them are basically have the capability of the call home, and we're going to exercise both of them connecting to the AMCOP SMO. Okay, so this is the topology. Yeah, so let's take a look into the demo, right? Live demo itself. Okay, so what? So you can see my screen, right? So I have multiple shells here. One of the shells is for the ConfD, right? This one is for my troubleshooting, and confd.command is another shell from where I'm going to invoke the call home feature, because basically the radio unit or the netconf server should have a way to provision and trigger it, right? So it is based on how the netconf server has implemented that functionality. So in the confd case, there is a separate application through which you can trigger it also. So this shell is I'm dedicated for that. And on the shell 3, you have a NetOPER 2 server. We'll demonstrate this also. And so there is a certain configuration NetOPER 2 requires for the call home functionality to trigger and consume, right? So that I'm going to demonstrate from the shell 4 using a sysrepo. And the last shell, which is the current kubectl, I have marked it as kubectl, through which we'll see our deployment itself. So let's take a look at the kubectl. Get pods. So once you have AMCOP SMO deployed, you will see a bunch of pods got deployed and will be running for the AMCOP SMO functionality, right? So essentially, this is the pod which is responsible. Okay, and this is what I was mentioning in the slide, that we need to provision some configurations initially to accept the global credentials and accept the SSH key coming from the ConfD in this case, or either it could be NetOPER 2 server. Okay, so which port it is listening, that is which I was mentioning. Let me show that. kubectl. Okay, so here if I landed to the application pod, if I just do netstat and try to grep for the standard port 4334, you will see it is with no response. But if I try and put it first, the other parameter 666, and if you see the net SDNR is essentially listening on that port. Okay, and what we are going to do is we're going to tail to the logs of this application, so that we'll see that the connection got established or not, right? And we'll also see from the server itself that the connection got successful or not. Okay, so let's take go to data logs. We can do tail NSF graph logs. Okay, so let it tail here, and let's go to the very first one, ConfD. We'll start the ConfD, which is your NetOPER, which is your netconf server in this case, right? And we'll also check from here that what are the configurations which I have shown, in order to accept the configurations from the SSH various keys and the user credentials from the global perspective, which is showing here. The username is admin and password is admin and netconf. So for ConfD, it is admin which will get used, and this password also admin will get used. Okay, when we'll go for the netoppeer 2, second device, that time, we'll change this field to netconf, and the password will still remain here the same netconf only. Okay, let's go to, okay, so this is the command, from ConfD perspective, through which you can trigger the netconf call home. Okay, and this is SSH call home, so that's why you have to specify this way the format. And the point to note here is we are using port 30666, not 666. Basically, in our deployment here, what we have done is, let me just come out of this deployment and show you that we have a mapping done. Okay, let's see. So if you look here, the SDNR application which I was talking, it is a node port. And so as part of node port, what we have done is we are saying that port 666 on which the application is listening, but for external, the port number would be 30666. Okay, that's how the mapping we have done. If it is a non-Kubernetes kind of deployment, right, in that case, directly this port would be exposed. Okay. So that's why you will see in the configurations coming from the netoppeer server or the ConfD, will be using this as a port to access it. Let's go back here and let's go to data. Let's go to this shell. Now I'm going to issue this command, and we will see that the session column session will get triggered from here, and automatically we'll see in the logs here the session gets established. Okay, we can just see that. Let's take a look. Cool. So as per the logs of the call ConfD, essentially the session got established. It says that, and config was successful in doing that. And after its connection established, it's able to, tear down also the session. That's what this logs determines that. If we go back here and look from the AMCOP SMO logs, right, from the application perspective, you see here, we will be able to see that call home has been, reported that someone has tried to connect to the AMCOP SMO. So you should be able to see it here completely. The call home dispatcher has been called, activating netconf channel, right? And this is for the device for which it is trying to do that. So this is the one. And then if you continue down, you'll see the column capabilities, basically, which is nothing but your netconf session. When it gets established, the capability will also get exchanged, right? So that you can see which is got triggered. And the device itself, the whole details has come up. So it is a, if you see the hello message capability, what SMO has received, it is talking about, it is a TLS ConfD basically. Right? So all the capabilities has been mentioned here in this part. So these are the capabilities of the RU in this case, in this demonstration. Okay. So this is one validation. Now what we'll do, we'll take it off this one, So let me stop this, and we'll exercise with a Net2Peer2 server to validate the column for that. Let's go back in the file and just see if we got any error messages or any log messages indicating that. Okay, I'll just do a Control C here so that we can take a look at the logs again. And let's go back to here number 1, and we'll change the credentials now because we need to specify the username as netconf for the Net2Peer2 server. So let me, I have the command handy with me. You can verify that whether it got succeeded or not. Yeah. Now username is now updated to netconf and the password remains the same what we did it. And let's go back to Net2Peer. So just you have to run Net2Peer2 server, and then essentially it should trigger the call home. But in order to do that, it needs certain configuration to be there in place. I'll just show you the configuration. Because Net2Peer2 uses sysrepo as internally as a data store, so it banks on some of the configurations there. So let's take a look at them. So as part of ITF netconf server, right, this is where you're going to define the column feature in the Net2Peer2. So it's listing on the various endpoints here. We also have a section for the call home. So here is the call home section. In this, what we're doing is we're specifying that under the SSS section that you have a TCP client parameter where remote IP address is this, which is IP address of the ORAN SMO, right? And if one has to connect on the port number 3666, right? So once you specify this configuration in your sysrepo, right, then once you start your Net2Peer2 server, it will trigger using this configuration in a SSH call home to the ORAN SMO. Okay, so this configuration is already in place, and one can verify other YANG files which is loaded here in this sysrepo. So here you can see these are the YANG files which are already loaded, and along with this you have two more YANG files which is from the ORAN perspective, ORAN operations and ORAN supervision. Okay, and one can verify that feature is enabled or not. You can see here the features are TLS call home, SSH call home, is both of them is supported by Net2Peer2 server, right? And it is part of the module ITF netconf server. Okay, so configuration is in correct state. Now let's issue a connection. So now you can see here from the Net2Peer2 logs itself, it is trying to connect to this, and it is successfully able to connect it also. Right, let's take a look at the application log of the Karaf. So here is the logs which has come up, will go up. And you can see here, this is the capability exchange which has happened between this device. Right, and like I was mentioning, you have ORAN working group 4 features. You have other ones also, ORAN operations here, and you have ORAN supervision.yang. So all of them got exchanged between the Net2Peer2 server and the ORAN SMO, right? And the connection status, if you see, it is got connected here. It's displaying that as well. So we do also have a way to demonstrate in the GUI, but essentially my setup is having some issue today, so I'm not able to show you the GUI. Otherwise, in the GUI, you should be able to see that as well. So the configurations which I did in the slides which I was showing you here, this configuration which I did, right, essentially you can do from our REST-conf interface. Let me see if it comes up. I may be able to show you that as well. Okay. Nevertheless, so this is primarily, demonstrating the capability of a netconf server. Netconf server connecting to an AMCOP O-RAN SMO, right, and able to perform the call home successfully between two different types of implementation of netconf server. Okay, so this concludes the live demo, and I think we can go to any questions which we believe we can take it up. Let me go back to the questionnaire session here.
Thanks, Yogen. We will just wait for a few questions. Yeah, I see one question. Is there any RAP running on SMO for call home? If yes, can you mention a brief about the RAP and if it is using O1 interface?
Are you saying a RAP?
Yeah.
RAP, you're saying?
RAP, yeah, RAP.
Okay. No, so in SMO, we are not running any RAP for that now. As an open source project, so Open Daylight has the capability of call home. So that is what directly getting utilized in this case.
Okay. Sending. Call home feature is supported only with SSH protocol?
So SSH is supported on the port number 4334. In fact, here we had a table where I was showing up all the port numbers here. So for SSH based, it is 4334. For TLS based netconf, it is 4335.
Okay. Okay, and I think few of them are will email us. If you can just go back to your the other slide, right, where info at Aarna Networks. They want to see that email. Yeah.
Yeah.
Yeah, I mean, I get a message saying that can we email you? So okay, this is the info at aarnanetworks.com. You can email your queries to us. Yep, I think we are done. And Yogen, I think you will be getting a lot of questions.
That's okay. I think that's welcome.
Yeah. Thank you so much. And we will be publishing the next meetup session, and I'll inform all of you soon. Thank you so much, Yogen. Thank you, everyone.
Yeah, thank you, Priya. Thank you, everyone.
Good day and good night.
Hey, thank you, Yogendra.
Yeah.
It was a nice session.
Yeah, thank you, Happy.
Thank you so much. Bye-bye, everyone.